In this video, we'll be exploring the Plot2D tool on Predictive Science's new MHDweb 2.0. This tutorial is part 3 of a 12-part series that is designed to guide users through this website's data visualization tools. If you have not done so already, it is recommended that you review part 1 of this series, which covers in greater detail this website's architecture, general visualization workflow, and the mass run database, among other things. So with that being said, to get started with 2D plots, navigate to the MHDweb landing page. Once again, that is predsi.com/MHDweb2 and click on the Plot2D button here. And for this tutorial, I'm going to select Carrington Rotation 2290, Thermo 2. As its name suggests, this tool extracts a two-dimensional slice from a three-dimensional dataset by linearly interpolating through a 3D dataset at some fixed scale value. For example, a radial slice indicates that the radial scale is fixed at some value here, and the theta and phi scales are interpolated through. The 3D dataset in question is some variable quantity that is derived from the running of the mass model, and that can be selected in the simulation widget from this variable drop-down here. And just quickly to reiterate something from Plot1D, which you can find in part 2 of this tutorial series, the variable drop-down menu here will default to the radial component of the magnetic field. However, you can also select, for example, velocity, current density, thermal pressure, as well as alpha and speed. Note that some of the variables' availability is contingent on the selected domain. So wave energy density, for example, both parallel and anti-parallel to the field, is available for coronal domains, but not for heliospheric domains. So moving on, the first widget that we're going to explore is the data widget in the upper left-hand corner. This widget is responsible for dictating which two-dimensional slice you will be extracting from the dataset. For a radial slice, you'll be extracting a long lat plot at the selected radial value, and for latitudinal slices or longitudinal slices, you'll be presented with a polar plot at a fixed theta or phi value, respectively. When no value is supplied in this slice value field here, we provide the midpoint of that scale. And just to reiterate, although this is covered in other tutorial videos in the series, when no value is provided for a field, or if a provided value in some manner results in a validation error within the plot generation routine, a modified value will be provided. And if you hover over the field in question, a tooltip will pop up with a more descriptive message detailing why the value is modified. So in this case, it says no value is provided, and so the modified value, or the value that is returned from the backend, is 180 degrees. Similar to the Plot1D tool, the data widget also defines how the selected 2D slice is transformed. So a slice can be logarithmically transformed, taking the absolute value of, or radially scaled by some power n. So right now we're looking at r squared, but we can look at r cubed, r to the fourth. And also one thing to keep in mind when doing logarithmic transformations, if you're looking at, for example, in this plot, the radial component of the magnetic field, you'll have negative values, so taking the logarithmic transformation will supply nan, or not a number values here, so the plot can look a little bit funky. Just keep that in mind by examining the original Colorbar scaling before applying that transformation. And lastly, with the data widget, you have the ability to customize stylistic components of the two-dimensional plot by pressing this button here. You'll be presented with the units that you'd like to use, whether real or physical units, or the native mass code units. You can remove the text, like this slice text here, and change the color map by pressing this button as well. So if I click here, you'll see a menu where we supply a wide range of color maps. These are pulled from Matplotlib, Sunpy, and PSI's own bespoke color maps. Hovering over any of these color maps will provide you with the name or identifier of that color map. Also at the bottom of this overlay, you can reverse the color map sequencing by toggling this button here. When selecting vector quantities as your variable, this tool defaults to a diverging color map to better express the underlying data structure. However, for scalar quantities, a sequential or linear color map will be used for the same reason. So for example, right now I'm looking at a magnetic field, but let's say I wanted to take a look at temperature. You'll see that the color palette has changed to a linear color map. With that being said, after selecting that variable, if you'd like, you can simply go back to this color palette option and select any one of these color maps from here, for example, like so. Now, if at any point in your data visualization workflow, you don't necessarily like the options that you've selected and are not quite sure how to change them back to the original, you can simply select this Reset Values button, and that will provide you the plot you'd see as a first-time user of the Plot2D tool. The next widget that we'll explore is the point widget. This widget allows users to query a plot at a specific position. By pressing this option here, this feature will be activated. As with the data widget, when no value is provided, default values, the midpoint of the two independent scales, will be used. So as you can see with this radial slice, the particular position in three-dimensional space is going to be at a radius of 15.5 solar radii and with a longitude of 180 degrees and latitude of 0 degrees, which are the midpoints of those respective independent scales. And similar to the data widget, you're able to modify certain stylistic components by selecting the Customize Style option. One thing that can be particularly useful is this line color selector. Oftentimes the line color overlaps with the color map that you've provided, and so to provide the crosshairs or point value that has better contrast, you can select from this option here. Similar to the Plot1D tool, you have these other options here to adjust stylistic components for the queried point. You can show the point, toggle on and off the crosshairs, or determine whether or not you want to show the text up in the upper right-hand corner, as well as change symbols, line width, and line style. And now moving on, we'll take a look at the view widget. So I'm going to toggle off the queried position and examine this in a little bit greater detail. So this widget is provided to allow users the ability to specify what subset of the slice data that they wish to view. So this is identical to the Plot1D view widget with the addition of this Colorbar Scaling dropdown. So suppose you wanted to zoom in on this area of interest within the plot. You can use the x-axis and y-axis limits to do so. By simply toggling these drop-downs, I can specify x-axis limits or longitudinal limits between, say, 120 degrees and 240 degrees. And then I can similarly adjust the y-axis limits or the latitudinal range between, say, negative 25 and 25. Now, as you can see, by zooming in on this plot, the y-axis tick labels are now no longer visible. With that being said, you can adjust where these tick values lie on the plot with these fields here. And so I can input a value that is more appropriate for the zoomed in portion of the plot. So instead of 60 degrees longitude, say I can do 30, and for the latitudinal axis, I'll put in 5 degrees. So similarly, you can do this for the polar plots that are generated through latitudinal and longitudinal slices. So let's say I'll go ahead and take a look at a longitudinal slice here. Since we're now considering a polar plot, the x-axis and y-axis dropdowns here refer to different elements of the plot. So this dropdown is referring to the degrees latitude, and this dropdown is referring to solar radii. Suppose you wanted to not view the entire coronal domain and you wanted to restrict it just between 1 and 5 solar radii. You could input that in the y-axis view limits, say between 1 and 5. And that would be effectively zooming in on this inner coronal domain here. And by doing this, by zooming in on this portion of the plot, it articulates some of the detail and nuance that you can find right around the photosphere here. So with that being said, I'm going to remove this upper limit for the radial scale. And we can move on to examine the Colorbar scaling in a little bit more detail. So by default, vector quantities, with the exception of the radial component of velocity, will default to a symmetric scaling, which you can see here. If no value is provided in this field, the default is the average of the absolute value of the given slice. This is just used as a general guideline to avoid over or under saturation of the plot. Now suppose you wanted to examine the radial component of velocity. You'll see that, as we mentioned earlier, the color map has changed to a linear color map, but also the symmetric color bar scaling has been toggled off. When no values are provided in the min and max fields, we simply supply the absolute minimum and maximum of the slice that is shown. So these changes to the plot color map, the scaling, and even certain slice transformations are just an attempt, as far as the backend is concerned, to provide a reasonable plot when exploring different variable quantities. But keep in mind that changes to the variable menu here will yield changes or side effects in other widgets. So just to reiterate a point that I brought up in part 2 of this series, examining Plot2D, is that a common pitfall when exploring these tools is that changing certain fields, namely fields that dictate what particular data set or subset of that data is being viewed, will have side effects on related fields. So it's important to keep that in mind when presented with a plot that does not necessarily align with expectations. So what I mean by that is that suppose in this plot where we're examining the radial component of velocity, I have scaled this to some static values, let's say between 0 and 400 kilometers per second. So this is a reasonable range for velocity. But let's say in making other changes, I examine, let's say I want to take a look at temperature. Now the color bar that we're referring to, these static values of 0 and 400 are no longer an applicable range for temperature, which is being measured in megakelvin. So therefore you get a plot which at first glance seems to not make sense until you consider that you can reset these values to their default and get a better sense of what the scaling is for this slice by examining what the minimum and maximum value are here. So as I mentioned in the tutorial for Plot2D, you can download the image that you're viewing with this button right here, or you can also download the underlying data that is used to generate this Plot2D by selecting this option here. The data that we provide is formatted in HDF4 or HDF5 file formats. Now, with that being said, that concludes this overview of the Plot2D tool on Predictive Science's MHDweb 2.0. The next video in this series will go on to explore the Data Products tool, or coronal hole maps. If you have any questions, comments, or concerns, please leave a comment below. And thanks for watching.